Let's look now at some of the properties of electricity. Electricity is simply the flow of electric charge, and it's usually described or measured according to three properties. It's current, voltage, and resistance. The current is just the measure of a rate at which electrons flow through my system. The higher the current, the more electrons are flowing through at any given moment. The voltage is essentially the force that are pushing electrons through the wire at any given moment. So the higher the voltage, the higher the force, and sort of the harder the electrons are working as they move through my system. Resistance is a measure of a material's opposition to the flow of electric current. We can kind of think of it as an electrical friction. So resistance is typically a bad thing because it causes us to lose some electrical energy as heat as the current flows through a wire or some other electrical system. So these three properties, current, voltage, and resistance, are related through Ohm's law. So this is the nice triangle that represents their relationship, but we can rewrite this equation in three different ways. So current is measured, or is abbreviated here with I, voltage is abbreviated with V, and resistance is abbreviated with R. So we can think of three ways to kind of rearrange this equation depending on what we wanted to solve for. So on the one hand, if we wanted to solve for current, current is equal to voltage over resistance. So current I is equal to voltage divided by resistance. On the other hand, if we wanted to solve for resistance, that would be resistance is equal to voltage over current. So if we want to solve for this piece, we just look at the other half. Meanwhile, finally, the last way we can rearrange it is we want to solve for voltage, and then we look at these two pieces. So voltage would be current times resistance. So we can use the triangle to figure out which one of these three relationships is going to be most useful. They're all the same thing. They're just rearrangements of the same equation, Ohm's law. It just depends on which one we want to solve for. A note on our units, when we plug them into this equation, the current must always be in units of amps or amperes. That's an A right there. There we go. The resistance is in units of ohms, and the voltage is in unit of volts. So we need to make sure they're in these basic units before we plug them in, or they won't cancel properly when we do our math. So let's look at a couple simple examples of how to use these relationships. So notice I keep my triangle up there so we can solve for that guy. A coffee cup immersion heater utilizes a heating coil with a resistance of 8.5 ohms. Determine the current through the coil when operated at 120 volts. So first of all, let's just establish what we have. So we have a resistance, right? A resistance of 8.5 ohms. It's operating at 120 V, so we should recognize that V is a measure of voltage. So it's operating at 120 V, and it's asking for the current. So the current is the piece that we don't know, and that's going to end up in units of amps. So since we're solving for I, we'll look at our triangle up here, and we see that the current is equal to the voltage divided by the resistance. So we just need to plug in our numbers. So our voltage is 120 volts. Our resistance is 8.5 ohms. So 120 divided by 8.5 gives me approximately 14. And the units we're going to get out for my current is going to be amps. So my current is going to be about 14 amps. Really simple, just establish what you know and the piece that you still need to solve for. Let's look at another example where my units aren't perfect before I need to plug them in. So a stun gun delivers about 1200 volts. So, okay, my voltage is 1200 volts, resulting in an average current, all right, it's going to give me my current, of approximately 3 milliamps into a human body. Using these figures, estimate the resistance. So I don't know my resistance, which is always measured in units of ohms, of the human body. So we see we have the three pieces that go into the triangle, but we see also that my current isn't in amps yet, it's in milliamps. So when that's the case, we just need to do a quick conversion. So my current is currently 3 milliamps. So we need to get rid of the milliamps and put it in just regular amps. And milli is just a metric prefix, so we're going to use the exact same relationships we used previously. 1 milliamp is 0.001 amps. So we do the math, my milliamps cancel, I end up with amps, and if I multiply, that gives me 0.003 amps. Now I have a voltage, a current, and I just need to solve for resistance. So resistance is equal to voltage over current. So in this case, 1200 volts over 0.003 amps. So 1200 divided by 0.003 gives me a very large number, 4 times 10 to the 5th. And resistance is going to give me in units of ohms, so about 400,000 ohms. So we can see that the resistance of the human body is very, very large. So anytime you have these three pieces, you need to interchange. Just figure out what you have, which piece you don't have, and make sure they're in the standard units of, for voltage, again, that's volts. For current, that needs to be in amps. And for resistance, that needs to be in ohms. If they're in milliamps, millivolts, kiloohms, anything like that, just turn them into regular volts, amps, and ohms, and then you can plug into the equation and go from there.